Day 11. This is yet another review for our upcoming test on nth roots and fractional exponents. You should be able to do this without using a TI-30. I will let you use a 4-function calculator, so practice that. And most importantly, do not have a pencil in your hand right now. If you're watching this video, you should be watching it to learn about the ones that you didn't understand. But I want you to go back and do the problem by yourself later. And really, you want to make sure that you can do the problem yourself, ideally several hours later, not like 2 minutes later. So that test is coming. So I've had a couple of kids say to me, Mr. Burton, I'm doing the homework Burton style. I'm going back and making my corrections, and I'm still failing the quiz. And I'm telling them what you need to do is wait longer between when you watch the video and when you do the problem, to see if you can still remember an hour, 2 hours, 3 hours later. Anyway, let's get started. Fourth root of 2,401. Okay, is that on the table? 2,401. That is a perfect fourth power. So let's just go ahead and do that immediately. The fourth root of 2,401 is 7. So I will immediately have 7 to the second power, which is 49. So that is it for number 1. Now, number 2. The fifth root of negative 7,776. Because it's an odd root, this is okay. It'll just be a negative number. But let's see if this is a perfect fifth power. Alright, fifth power. There it is. The fifth root of 7,776 is 6. So for that reason, inside the parentheses, I will simply have negative 6. So that's negative 6 to the third power. Now 6 to the third power, I believe, is 216. Yep, 6 to the third power is 216. Now when you have an odd power, that negative stays. So this will just be negative 216. Alright? If this had been an even power, like 2, 4, or 6, the negative would have gone away. So that is the answer for number 2. Number 3, cube root of 729. Let's see, cube root 729 is 9. Okay, so that is going to give me 9 to the fourth power. Okay, 9 to the fourth power is 6,561. So that will be 6,561. Yeah, just checking. Alright, let's move on to number 4. 25 to the 5 over 2 power. You want to rewrite this in radical form. In radical form, the numerator is the power and the denominator is the root. So that means I have the second root, or square root, of 25 raised to the fifth power. Of course, the square root of 25 is 5. So that's just 5 to the fifth power. Okay, 5 to the fifth power is 3,125. So 3,125. Okay, number 5. There's more than one way to do this, but the way I like to do it is if you have a negative exponent, this entire expression needs to drop down. So I'm going to take this whole thing and drop it to the bottom. Okay, so this is going to become 1 over negative 1024 to the positive 2/5 power. Okay? So now I just need to execute this down here. So I will rewrite this denominator in exponent form, similar to what I did before. So I will have 1 over, let's see, this is the root, this is the power. So this is the 5th root of negative 1024. And then 2 is the power, so squared. So let's see, what is the 5th root of 1024? 5th root 1024 is 4. So since it's a negative 1024, it'll be a negative 4. So I have negative 4 squared. Now this is an even power, so this is going to turn positive. So I will have 1 over 16, positive 1/16. And that is the answer for number 5. Alright, number 6, same thing. This is negative 3/4 power, so because of the negative exponent, this entire thing needs to be dropped to the other side of the fraction. So I'm going to have 1 over 2,401 to the positive 3/4 power. Okay? So that is going to give me, if I rewrite this in radical form, that's going to be 1 over 4th root. So I'm going to have the 4th root of 2,401. Hold on, I have to make a better 4 than that. Alright, 4th root, and then the 3 is the power, so all of this will be now cubed. Okay, and I'm going to bring this up over here. Alright, so first of all, the 4th root of 2,401. So 4th root 2401 is 7. Okay, so inside of the parentheses I will have 7. And then it's still to the 3rd power. So that'll just be 1 over whatever 7 to the 3rd power is. 7 to the 3rd power is 343. So that's 1 over 343. So that is the final answer for number 6. Alright, number 7. Alright, well, we've got our negative exponent, which tells us that this expression is on the wrong side of this invisible fraction line and therefore must be dropped down. So this is going to become 1 over negative 3 to the 4th power. So I just need to do negative 3 to the 4th power. Because it's an even power, the negative is going to become positive. So this will just be 1 over 81. Okay, and of course 3 to the 4th power is 81. So that's how I knew that. But it's positive. Oh, yeah, number 8. Okay, now the easiest way to handle this problem, since all the bases are the same, negative 2, negative 2, negative 2. Easiest thing to do is to add up all the exponents right now and just keep this base. So negative 2 to the. Negative 3 plus 5 is 2. Alright, 2 plus 7 is 9. So this is really negative 2 to the 9th power. Because it is odd, an odd power, the final answer is going to still be negative. And by the way, you can't leave it like this. Alright, you have to, you can't have any parentheses in your final answer. And since I'm letting you use the table, you have to go ahead and give me the big number. So we have 2 to the, oh wait, 9th power though. That's off the chain. Okay, 9th power is too much. It's much too much. Okay, well, you still are not allowed to have parentheses, but I am going to let you keep the ninth power since that's far off the chart. But without parentheses, this is still going to be negative because it's an odd power. So you could just put negative 2 to the ninth power and leave it like that. That would be your answer, number 8. So no parentheses, negative stays. Number 9. Now, let's see, there's many ways to do this, but when you have a negative power on a fraction, probably the easiest thing to do is to do the reciprocal first. So a negative number on a fraction, that is going to give me x over negative 2 to the positive 4 power. Okay, you can do the reciprocal and then it becomes a positive 4. So now I can just execute the 4th power on everybody. So that is going to give me x to the 4th power in the numerator. And when I go to do negative 2 to the 4th power, okay, look, I know that 2 to the 4th power is 16. So guess what? Negative 2 to the 4th power is also positive 16. Because it's an even power, the negative is going to go away. So no matter how you do it, this is what you should have. Alright, another way you could have done it would be to stick the negative 4 on everything. So for a minute, I would have negative 2 to the negative 4 power, and I would have x to the negative 4 power. Now if you look at it this way, then you're going to say, oh look, this has a negative power, it's going to drop down. This is going to go up for the same reason. And if you do that, then you end up with x to the 4th power over negative 2 to the 4th power. And then that brings you right back here again. So either way you want to look at it, same result. Number 10. When you have like bases like this, you add the exponents. So what we are doing to multiply, we're doing a to the 1/2 plus 2/3 power. I usually add these off to the side somewhere, so 1/2 plus 2/3. Let's make these denominators into 6's. So over here I'll multiply by 3, that'll give me 6. And over here I'll multiply by 2 to get the 6 in the denominator. So that gives me 3 over 6 plus 4 over 6, which is 7 over 6. Okay, so that means I'm going to have a to the 7 over 6 power. And since the original problem is in exponent form, now that we have this down to just one factor, we will just leave it in exponent form. Alright, number 11. Let's see. So I'm going to do this 5th power to everything. Now when I do the negative 2, remember I'm doing negative 2 to the 5th power. I'm not multiplying, it's not going to be negative 10, it's negative 2 to the 5th power. And so 2 to the 5th power is 32. So that means negative 2 to the 5th power is going to be negative 32. Okay, because it's an odd power, the negative gets to stay. Now, as far as the variables go, I am multiplying. So 2/5 times 5. This is going to wind up just giving me x squared. Okay, now in my mind, I just do this. I'm like, oh, when I multiply, those 5's are going to cancel, and that's just going to leave 2. That's how I was able to do it so quickly. But if you can't handle that, if you're not on my level, then you might do something like this. Let's see, 2/5 times 5. Okay, that's like 5 over 1. 2 times 5 is 10. 5 times 1 is 5. So that it gives you 2. Okay, and that's, oh look, that's the 2. So if you need to do that, hey, do what you got to do. Now, me, here again, when I get to the y's, again, this 5 and this 5 just cancels out. So I will just have y to the 1 power, which is just y. So guess what? That's the answer. I'm done. Okay? But again, if you can't handle that, then you could have done this. 1/5 times 5. Look, let me clean this up. Okay, when you go to multiply 1/5 times 5, you might think like this. Alright, I've got 1/5 times 5. And this 5 is really like 5 over 1. So 1 times 5 is 5. 5 times 1 is 5. So that's 1. Okay, so that's why this is y to the 1 power. Okay, whatever you got to do, that's what you got to do. Now, because the exponents are the same, I can divide. If these exponents were different, I could not divide. But I can divide because the powers are the same. So 55 divided by 5 is 11. So that is going to give me, on the inside here, 11 to the 1/4 power cubed. Okay? And then when I multiply, that's going to give me 11 to the 3/4 power. And that's it. Okay? And again, I'm just doing 3 times 1 and 1 times 4. That's 3 over 4. So, it started off in exponent form, so I'm just going to leave it in exponent form. How about that number 13? Alright, so I've got 15 over 60. I should definitely reduce this. Now, 15 actually divides into 60 evenly. Alright, 15 goes into itself once. 15 goes into 60 4 times. Okay, if you don't trust me, just do 60 divided by 15. See, told you. Whoa, too big, too big. Anyway, so that's going to reduce right there. So far, I've got 1/4. Okay, so this is the situation. So far, I've got 1/4. So now I need to deal with the x's and the y's. I'm just going to show those separately. Now look at the x's. I've got x to the 1/2 minus 2. When you divide, you subtract, right? So I need to do 1/2 minus 2. And then when I do the y's, you can think of this as y to the 1 power. So that'll be 2/3 minus 1, right? 2/3 minus 1. Just do them separately. Now, to do this, you need like denominators and stuff. So, and I usually do this off to the side somewhere. So looking at the 1/2, all right, maybe I can do it on this side. Yeah. So off to the side, if I do 1/2 minus 2, okay? So first of all, that's like 2 over 1. To make these like denominators, I could just multiply by 2. So that'll give me 1/2 minus 4 over 2. Now 1 minus 4 is -3. So look, that is -3 over 2. That's what's happening right here. So this is going to give me x to the -3 over 2 power. So basically, it's like at first, that's sitting right here, x to the -3 over 2 power. Everything starts off in the numerator. But of course later I'm going to have to drop that down. Let's do the same thing with the y's. Alright, off to the side, if I do 2/3 minus 1, okay, let looking at this as 1 over 1, I can quickly change this into 3/3. So I've got 2 minus 3. 2 minus 3 is negative 1. So I've got negative 1/3. Okay, and that is what is happening right here. So I've got y to the negative 1/3 power. Okay, so temporarily, I'm just going to put that here. Everything starts out in the numerator until you move it. Okay, when you do the subtraction. So because these are negative, they are going to wind up on the bottom. Okay, and I'm going to have to erase some of this stuff to make space for the rest of my work. Okay, so this is going to give me, alright, let me sequester this. So I will have 1, and I've got the 4, but these two things have to drop down. So this is going to drop down, and this is going to drop down. So I'm going to have x to the 3 over 2 power at the bottom, and I'm going to have y to the 1/3 power at the bottom. And this will be your final answer for number 13. Alright, 49 to the 4th power. This is going to be a crazy big number, so I'm not sure why we're doing such a big number, but we are. So look, for right now I'm just going to leave it just for a second. 49 to the 4th power. These variables I'm going to have to multiply, so that'll be x to the 32 power. I'm multiplying right there. Then I'll have y to the negative 6 power. Now, let me show you what I did. Now, me personally, I went like this. I went, okay, 2 will divide into 4 twice. And negative 3 times 2 is negative 6. That's what I did. Now, if that's too confusing for you, then you could do it this way. Negative 3 over 2 times 4 over 1. Okay, negative 3 times 4, that's negative 12. 2 times 1 is 2. And then that's going to give you negative 6 when you divide. Now, anything with a negative power, like this, is going to have to drop down to the bottom. So that's why in the end, okay, so 49 to the 4th power. Obviously, this is not on the chart. Alright, it only goes up to 10, not 49. However, I could do this in a bootleg calculator if I wanted to. Just do 49 times 49 times 49 times 49. Whoops, wrong button. It won't be quite as tidy as this, but it works. 49 times 49 times 49 times 49. That's 49 to the 4th power. So you should get, okay, 5,764,801. Can I remember that number? I don't know. Okay, so it was 5,764,801. So that's 49 to the 4th power. And then I've got my x to the 32 power, and this dropped down. So down in the bottom I have y to the 6th power. And this would be your final answer for number 14. Alright, it's time to simplify this 5th root. And to do that, we always break things down. And I like to use color. You maybe should do the same. Because I'm doing the 5th root, I'm going to check the 5th power column for 64. 5th power column, there's 32, no 64. So since 64 is not here, I need to find something that divides into 64 that is here. 32 is the only thing that had a chance of being less than 64, and it actually does divide evenly in. I could write 64 as 32 times 2. Okay, see, I factored 64. I just split it up. It's 32 times 2. I'm making the 32 pink because 32 is the number that's on the list. That will simplify later. Now the variables. When it comes to the variables, you need the exponent to be divisible by the root. So I need this to be divisible by 5. The first number that is divisible by 5 under 12 is 10. So I will split this x to the 12th apart as x to the 10th and x squared, total of 12. 18 is not divisible by 5 either. The first thing that is y to the 15th. But that's going to leave 3 y's left over. So everything here in pink can be simplified and brought outside of the radical. The fifth root of 32 is 2. So I will have a 2 outside the radical. The fifth root of x to the 10th is x squared, because to do this you just do 10 divided by 5 is 2. The fifth root of y to the 15th power is going to be y to the 3rd power for the same reason. 15 divided by 5 is 3. Now, this will be outside the radical. Everything shown here in blue will be stuck under the radical. So I will have the fifth root of 2 x squared y to the 3rd power. So this would be my final answer for number 15. Number 16. The numerator and the denominator are both able to be simplified just the way they are. 16 is a perfect 4th power. See, if you look at the 4th power column, you see the 16. So the 4th root of 16 is 2. So we can go ahead and just do that immediately. Okay, so the numerator we have 2. Similarly, in the denominator, 4 is a perfect square, right? This is a square root. So the square root of 4 is 2. And the square root of x to the 12th power, you are dividing by this invisible 2, which is understood. So, 12 divided by 2. So that's going to be x to the 6th power. Similarly, we will have y to the 3rd power, because I'm just 6 divided by 2. Now, these 2's are going to cancel each other out, alright? 2 goes into itself once, both times. So that's why the final answer for number 16 will be 1 over x to the 6th power, y to the 3rd power. Okay, so there's your answer for number 16. Now, these questions are possible bonus questions. Alright, so don't worry, because you don't have to be able to do this for the test on Friday. But if you can learn how to rationalize denominators right now, you may get an extra 5 points or so. Maybe. No promises. Now, rationalizing denominators with fractional exponents, that means that once you rewrite it in exponent form, the denominators should only have whole number exponents. Alright? Only whole number exponents in the denominator. No fractions on the bottom. No fractional exponents on the bottom. So it's a matter of looking at number 17. I see that fraction of 1/5, fraction of 2/3. How can I get rid of that? And here's what you do. focus on the c to the 1/5 power for a moment. So we've got c to the 1/5 power. Now, I'd like to get rid of this 1/5, but I have to be careful not to break any rules. I can't really change anything. But imagine that somehow I could add 4/5 to this. Imagine I could do that. What would happen? Well, 1/5 plus 4/5 is 5/5, which is just 1. So that would just give me c. So not only would I have no fraction left, but I would have no exponent left at all. So this is going to be our strategy. If I have 1/5, I'm going to try to add enough fifths to it to make one whole, which I can just cancel out. Now remember, if I want to wind up adding these numbers in the exponents, all I really have to do is multiply by c to the 4/5 power, because you know that if I multiply like bases, I wind up adding the exponent. So this would give me c to the 1/5 plus 4/5, which would wind up being c to the 1, or just c. Now this I can do. I can multiply by c to the 4/5 power if I want. And in fact, see, watch me do it. I'm awesome like that. I'm cool like that. So if I multiply by c to the 4/5 power, that's legal as long as I do the same thing in the numerator. So I will put c to the 4/5 power up here as well. And as you just saw, this is going to wind up making c, alright, because I'm going to wind up adding, and I'm just going to get c later. So I will see you later. So far, in the top, I've got a to the 3/4 power. In the bottom, I have just c, because we did all this. We multiplied these, this happened, we just got c. But in the top, now I have c to the 4/5 power. So far, so good. I got rid of the 1/5. Now I just need to do the same thing with the b's. Let's see, let me do a different color this time. I'll do green. Now, with the 2/3, how many more thirds does it take to make one whole? Well, I want a total of 3/3. So if I multiply by b to the 1/3 power, I'm going to wind up adding 1/3 plus 2/3. Okay? So if I'm going to multiply by b to the 1/3, I have to do that in the bottom and the top. Okay? So let me erase all this so I can do it over again. So now look at the b's. By multiplying by b to the 1/3 power, then this is what I have. I have b to the 1/3 power times b to the 2/3, which was already sitting there. Okay, and you know that when we multiply like bases, we'll wind up adding these powers. So this again will be b to the 1/3 plus 2/3. But just like we wanted, this will make 3/3, which is just 1. So that'll just be b once these cancel out. So that's what you want to do. Alright, you want to multiply by the right power so that when you add, you will get one whole, which cancels out. So now I've got b in the denominator because of this process, but in the top, I still have this b to the 1/3 power. That was a terrible 3. Let me try that again. 1/3 power, I say. Now it's traditional to put these in alphabetical order. So if you're OCD, alright, which I am a little slightly, then you will go ahead and put a to the 3/4 power, b to the 1/3 power, c to the 4/5 power, all over BC. Okay? Now, please understand, we are not simplifying. Okay? This is not simplified. In fact, the original problem was already in simplified form. What we just did is called rationalizing the denominator. And yeah, why would you want to do that, or why would you care? You know what? I don't know. I'm just going to be honest with you. But maybe you'll find out in pre-calculus. You can come back and tell me. Now, pause the video, okay? Because I guarantee you did not know how to do that the first time. So obviously you had to watch the video to learn it. But now that you saw me do it one time, go ahead and try to do number 18 on your own. I'll wait while you pause. Did you pause? Or are you just messing with me? Alright, well, I'm just going to pretend that you paused the video and did the problem on your own. And now let's see if you did it right. Well, on this one, in the denominator, we have 8. That's already fine. There's no problem with that, so I'm going to ignore it. We just need to get rid of this 8 over 11. So I need to multiply by the right y. That will make this 11 over 11. Well, 8 elevenths plus 3 elevenths would make 11 elevenths. And that's my goal, is to make one whole. So I'm going to multiply by y to the 3 elevenths power. And I have to do that in the top and the bottom so that it is legal. Alright, that way I'm not really changing anything as long as you do it both places. So, maybe you'll let me get away without having to show this addition again. But now in the top I have 3y to the 3 elevenths power. In the bottom I'm going to have x to the 8th and y. Alright, again, you know what, I'll show it just in case you are intellectually challenged. You understand, if I'm doing y to the 8 over 11 times y to the 3 over 11, I would have to add these powers. So that would give me y to the 8 elevenths plus 3 elevenths. But 8 plus 3 is 11, so that would be 11 elevenths, which is just 1, which is just y. And that's why it's just y. Now, having seen that a couple of times, I'm really hoping you can do all this green stuff in your head and just go, oh, 8 plus 3 would be 11, so it's y. Boom. Anyway, that is the final answer for number 18. How did you do? Alright, did you get it right on your own? Did you even do it? Alright, I'm going to give you one more chance to pause the video. Try to do number 19 by yourself. Pause the video now. Now, you and I both know that you did not pause the video. But I'm just going to be too polite to mention it. So let's just move on. You know what you did. You know what you did. We'll see if you get it right on the bonus on Friday. And then what you look like. Alright, on this last one we have 3 different fractional exponents that we have to get rid of. So, let's just do this in our head. I don't feel like doing all that stuff off to the side this time. So let's look at each one separately. If I want to get rid of the 1/4 here, let's see, 1/4 plus 3/4 would make 4/4, which would be a whole, which would cancel out. So that's why I'm going to multiply this one by g to the 3/4 power. Alright, if I want to get rid of the 1/2 power, that r, then I'm going to multiply by, let me go ahead and do the s since it's right here. For the s, I have 2/5. Alright, if I were to do 3/5, alright, I'd wind up adding, and 2 plus 3 is 5, so that'd be 5/5, which would cancel out. But I also need to cancel out the r to the 1/2 power. So also imagine that I multiply by r to the 1/2 power again, because I will wind up adding the 1/2 and the 1/2 if I were to do that. And a half plus a half is a whole, 2/2. So this is what I would have to multiply by to cancel out all of these exponents. Okay, so doing that will give me a denominator of simply, well, that looks like a G. That's garbage. It's supposed to be a Q. Alright, so that would give me simply Q, R, and S with no exponents left. Meanwhile, in the top, you see I have 4p to the 5th power sitting there. So that's still going to be there. So I've got my 4p to the 5th. But in addition to that, everything I just did in the bottom, I need to do the same thing in the top. Q to the 3/4 power, S to the 3/5 power, and R to the 1/2 power. It all needs to go up there, same thing. So in the numerator, I'm just going to recopy all these things. Alright, so I'll have p to the 5th power, which was already there, and q to the 3/4 power, r to the 1/2 power, s to the 3/5 power. And this is not simplified, do not get it twisted, but we have rationalized the denominator. There are no more fractional exponents in the denominator. Alright, and that is it for this lesson. Maybe I'll put a few more of these on tomorrow's homework. We'll see. Alright, I will see you on the next video.